Okay, what we mean by that is when we apply the substitution, or when we have radicals, we can apply the following substitution. If you have, for instance, a radical that is the nth roots of some function, let's say g of x, right? We're going to replace it with a u, okay? And the following couple of examples demonstrate this. So the next example will be example 9, I believe. So in this example, we need to evaluate the integral of the square root of x plus 4 over x dx, like so. So when we solve this, based on this hint, we're going to let u equal to the square root of x plus 4. Now let's manipulate it a little bit before we take even the derivative. U square will be x plus 4, and since we have x in the denominator, then x by itself will be replaced by u squared minus 4. Remember, once we substitute, we cannot linger to term containing x. You need to substitute everything and keep only terms of u in the expression or in the integration. So now we can take the derivative and can say, okay, if x equals u squared minus 4, therefore dx equals 2u du, right? So we have this substitution. We're really interested in replacing the square root of x plus 4 dx. Okay, so now the numerator, the square root of x plus 4, I'm sorry, it's not x squared, just x. It's automatically I put x squared for some reason. So the numerator x plus square root of x plus 4 dx, I almost did it again, will be what? This is u, and this is 2u du, so we're looking at 2u squared du. And of course the denominator is u squared minus 4. So now the integral, the one they started with, square root of x plus 4 dx over x, looks like this. The same bride with different dress. We have the two, so let's yank it out. And the numerator will be u squared du, and the denominator will be u squared minus 4. Okay? And here, if you remember the very first example, in this case, the degree of the numerator is not less than the degree of the denominator. So we need to perform long division or synthetic division. But if the degree of numerator and denominator is the same, you don't have to do it. You can do the following, perform the following trick. You add and subtract 4, or subtract and add 4. Okay, so you have u squared minus 4 plus 4 over u squared minus 4 du. And now you break it down into u squared minus 4 over 4, where that will be 1, plus 4 over u squared minus 4. Okay? Now, if you don't see this, then you perform the long division and you end up having the same result. And now we're ready to integrate. Okay? So, the integrate, we have 2 outside everything. And of course we have u. And what the heck is this integral? We have seen this before, and I told you, if you have x squared minus a squared, you have a shortcut. Remember, early when we started a partial fraction, we said if you have x squared minus a squared, you factor it as x minus a times x plus a, and the result was 1 over 2a times the natural log of x minus a over x plus a. And told you even that you can use it in the future, where the future is now. So this is a shortcut. A is 2. 1 over 2a will be, well, let's do it this way. 1 over 2 times 2. And then we multiply it by 4, because we have the coefficient, and then we have the natural log of u minus 2 over u plus 2. And here, we don't know whether u can be greater than 2 or less than 2, so we have to put in absolute value. And finally, the solution, we started with x, you need to end up with x, so you have 2 times u is the square root of x plus 4. Of course, this is 1, and then you have plus natural log of the square root of x plus 4 minus 2 over the square root of x plus 4 plus 2. And we still need to keep the absolute value. Okay? Did you like this example?